Hello students, in this video I would like to discuss about a fundamental topics in mathematics that is about sets notation. All right, I will start with the understanding of a set. A set, a set is collection of distinct objects. That's it. So a set is collections of distinct objects. For uh, for the next explanation, you can you can learn deeply about the understanding of a set. Okay, I'm going to continue to the objects in a set or members or elements of an object. If there is a set A sample, and if set A has elements 1, 2, 3. So these numbers are elements or members of this set. Uh, Sometimes the capital letters we using for the name of a set. Yeah, so like this, the capital letters A, or if you would like to using B as the name of the set, you can using this. So for example, if B elements are A, B, C, D. All right. So pay attention that if elements of a set, you have to using the the lowercase letters. Do not using the capital letters. Yeah. So you have to using the lowercase letters for the members of the elements. If the name of elements, you have to using the capital letters like A or B. Right. The next about the empty set, the empty set. Sorry, the empty set or the null set. The empty set. The empty set or the null set. Yeah. The symbol of the empty set or the null set, all mathematicians agreed that like this, or you can use it like this. Okay, the empty set or the null set. Okay. For example, if a set members x squared plus 1 equals 0. If you find x squared equal minus 1, and x square root minus 1, this is an imaginary numbers. Okay, so it means the set members, the set is an empty set or the null set without element, without members. Next, a finite and infinite set. A finite and an infinite set. A finite set, the understanding, a finite test, a finite set, a finite set is one which can be is one set which can be counted. Okay. Uh, I mean, the members or the elements we can count. For example, For example, of the set of odd numbers. The odd numbers. If the set if the set name is set C, for example, set C, I can write it like this. The odd numbers are uh, 1, 3, 5, 7, and so on. Okay, and yeah, infinite test, odd numbers less than uh, less than less than 10. It's been 1, 1, 3, 5, 7, 9. So this is the set C according to this information. So the members or the elements of set C are 5 elements. Okay, like this. So how about infinite set? An an infinite set. Uh, an infinite set is set, one set which cannot, it cannot, uh, it cannot be counted or cannot determine. Yeah, counted or determined. For example, the set, the set of odd numbers, greater, greater than, greater than 10, for example. If the set number, if the set, if the set name is set D, so we can write it like this: greater than 10, 11, 13, 15, and so on. So infinite. The members of set D are infinite. Right. Now, I would like to continue with the cardinality of a set. The cardinality of a set. The notation, the notation, the notations of the cardinality of us of a set is, for example, N A. What is the meaning? The meaning of NA is elements of set A or elements of or members of set A. So if the set is B, so we can write it like this. NB meaning uh, the elements of set B. Uh, and for example, yeah, this is for the finite set, not for infinite set. So uh, finite finite set. Okay. So how about for infinite? For infinite set, so for infinite set, the members or the elements, for example, set A, for infinite set, the members or the elements is of course infinite. Yeah. For example, if a set F, for example, set F elements are 1, 2, 3. So it means NF, we can write it as 3 because it has 1, 2, 3 members or 3 elements like that. And the next is about the universal set. The universal set, or the symbol is U. Scroll down. Okay. A set U includes all of the elements under consideration in a particular case discussion. So better if I write a set U that includes all of the elements under consideration in a particular discussion. Right. For example, the set of Latin letters. What else? The set of points on a line. Okay, the set of points on a line. What else? Uh, Scroll on first. The set of natural numbers. The set of natural numbers. Okay, okay, it's a lot. And the next about the membership of relation. Okay, the membership relation. I mean, the membership relation. Okay, the membership relation. For example, set B. Okay, if B is a set, B is a set, and elements or members one, two, and three. So one, two, and three are members of this set B. So we can state that one is element of B as well. Two is elements of B. So this symbol is symbol of elements. Okay. So one is elements of B. Two is elements of B. Three is elements of B. So how about if four? Four is not elements of B. This symbol meaning not elements of B. Yeah, as well, we can state that six is not elements like this, not elements of set B. Now, let's continue. We want to continue with equality of sets. Equality of sets. This. To sets A and B, A and B, okay, to sets A and B, okay, okay, let's continue. To sets A and B are equal, denote A equal B if they if they have same elements or members. Yeah, same elements of member. Otherwise, otherwise, if they have no same elements, it means A not equal with B. Set A not equal with set B. So if set A equals set B, it means all elements of set A same with all elements of set B. For example, uh, scroll down first. Okay. Set A. Set A elements, uh, the odd numbers. Odd numbers. The odd numbers between 4 and 8. Okay, so it means A are A elements are 5 and 7 here. And set B members, prime numbers between 4 and 8. So B elements are 5 and 7 as well. So we can state that. Set A equal set B. Like that. Next, about subsets. This one. A is a subset of B if every element of A is an element of B. Subset if A is subset of set B, so it means every element or members of the elements of A is the element of B. How about the symbol? The symbol, and also I would like to add, and also A equal B. Sorry, A not equal B. If subset, because A subset it means part. So A is part of B. Set A is part of set B. But the symbol is like this: A subset of set B. So set A is subset of set B, or you can writing like this: set A is subset of set B. For example, scroll down first. Okay, for example, like this: if set A elements are 1, 2, 3, okay, and set B elements are 1, 2, 3, 4, and 5. So we can state that A is subset of B, or we can state A is subset of B. So set A is subset of set B, or set A is subset of set B. So this is the symbol of subset. Also, this one is the symbol of subset, not C, but subset. What is subset? Subset is part of. So we can say that set A is part of set B. Set A is part of set B. Let's continue with unions. Okay. The union of two sets A and B is A union B. So this is the symbol of union. Okay. So the union of set A and set B is like this: X, which X element of A or X element of B. Like that. For example, if set A has element 1, 2, 3, and set B has elements 2, 3, 4, and 7. So it means we can state that set A union with set B elements are 1, 2, 3, 4, and 7, like this. So I mean, this is clear. Next, about intersection. The intersection, scroll down first, right? So intersections of A and B, you you have to write it like this. So this is the symbol of intersection. Intersection A, set A intersection set B equal X, which X element of set A, and so pay attention that just now for unions we use or, and for intersection we use and, the word of and. So A set A intersection set B equal X, which X element of set A and X element of set B, like that. For example, if set A is the set of even the positive integers. Meanwhile, B is the set of prime positive integers. So it means A elements are 2, 4, 6, so on. How about B? The elements are 2, 3, 5, 7, and so on. So look at the same elements is what? 2. Because there is 2 here as the elements of set A, and there is 2 here as the elements of set B. So we can state that A intersection B elements is 2. So So it means that cardinality set or n um, elements of A intersection B, how many elements of A intersection B and A intersection B equal 1 only, 1 elements. Okay. Now, the next example, if C 2, 3, 5, set C elements are 2, 3, and 5, and set D elements are 6, 9, and 10. So C intersection D, look, there is no elements as the intersections of as the member or the elements of C intersection D. So we can state that C intersection D without elements like this. So we can state that A and B, C and D, I mean. C and D, C and D are disjoint. So you have to memorize this term, this word. Okay, I'm gonna continue with the next lessons about complements. Okay. It's gonna be I need electricity first. Okay. If you what is you? You is universal. Yeah. In this lesson, in sets. If you if you are the positive integers, integers between 0 and 11. Okay, the positive, it means not include 0 and 11. So those numbers, those positive integers between 0 and 11. And A are numbers, even positive numbers between 3 and 11. So if you're writing the elements of universe, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Not include 0 and 11. So it means A are 4, 6, 8, and 10. Not in, between 3 and 11. So it means we can state that A is subset of U. Okay. A subset of universe or A subset of universe like this. Okay, now how about complement? If A complement, this is the symbol of complement, a complement are those numbers not include the elements of A. And those numbers are 1, 2, 3, 5, 7, 9. Yeah. How many numbers? 1, 2, 3, 4, 5, 6. So it means n, a complement equal 6. Thus, how about if we are going to find, a intersection with a complement? If you pay attention, these are the elements of set A, and these are the elements of set A complement. So it means there is no elements like this. So how about if set A union with the set complement? The union is universe. Those number here. Okay. Let's continue with the next lesson. It's about Venn diagram. Right. What is Venn diagram? Venn diagram are the diagrams that are used to represent the sets, relation between the sets, and operation performed on them. I'm going to write it here so you may copy uh, this understanding. So Venn diagram are the diagrams uh, that are used to represent the sets relation between with the sets relation. I mean, there is no comma here. Okay, there's a relation between the sets and operation performed on them. Okay. Yep. In a picture, in a pictorial way. So right. I will sketch first. So if we discuss about Venn diagram, it means we are going to sketch. Sketch what? Sketch the sets. All right. I would like to start with how we sketch the set, or sorry, how we sketch the Venn diagram of set A intersection set B, like this. And the Venn diagram like this. Okay, this is the Venn diagram. Okay, this universe. Okay, and if this is set A, this is set B. Uh, this area is the intersection of set A intersection set B. Next, how about if A union B? If A union B, the Venn diagram like this. So you can set the rectangle or square. And after that, create two sets, two circle like this. If A union B, it means all elements in A, okay, and plus all elements on set B. All right. How about complements? If A complements the Venn diagram, this if this is A, okay, this universe, it means uh, out of A, right? Okay. A complements, it means those elements not include of set A elements. That is the shading. The shading area is area of A complement. Also a complement if there are two sets A and B. This okay, let's see first. This is set A, set B. Uh, this the setting area are the area of a complement. So pay attention that including the elements of B are not include of A elements. Okay, so this is the conditions of A complements if there is an intersection between set A and set B. Also, how about if there are three? Okay, there are three sets A, B, and C. A complements is okay. A include of C. Yeah. Let's continue. How about the Venn diagram of a complement intersection with B, with set B. So the Venn diagram like this. Okay. The Venn diagram. Okay. See first. This is set A, set B. So A complements, it means all elements outside of A. I'm gonna using the different color. Okay, it's area not include of A. All right. Now we're gonna shading area uh not include of B. Sorry. A complements one. Yeah. The first shading area. And then intersection B, it means B. All elements of B is this shading area as well. So find the double shading area, this area. Okay. We're using the different color. This one. Yep, this one. Okay. So this area is the solution area, the elements, the intersection. It has the double shading. Okay. So this is the area of A complement intersection with B. Let's continue. How about if what if what else? A intersection set A intersection with set B complements. So the Venn diagram, this A set A set B is universe. Okay. First we need to find I'm gonna using this color A. Set A is one. This is the set A, set A, and B complements. B complements, but B complements not include of B are okay, this no, B. Okay. So now find uh, area the area which has two shading. Okay, this area. Okay. So this area has two shading. Okay, and this one, this area. So this area is the solutions area intersection between A and B complement. So this area. So how about if uh, A complement intersection with B complement, right? This is U universe A. B. The first step we need to find A complement. A complement are one not include of A. Okay. Okay, so this setting area is area of A complement about B complement. I'm going to use a different color. B complement, right? B complement, okay, not including of B. Uh, so which area has the double sharing area? This area. If you pay attention, this area. Okay, I'm going to use in different color. This color. This area this area, okay, this area, this the double shading area, this, sorry, this area, okay, so this area, okay, look, so this area, the double shading area is area of A complement intersection with B complement. Some students ask me, Mister, how about if A complement, set A complement, union with E complement? Okay. So my explanation like this: A complement include union plus B minus, sorry, I mean A complement, those elements of B plus those elements of A minus of U minus A, I mean, yeah, this. So about B complements. B complements are set A plus U minus B universe, elements of U minus elements of B. This, I mean, and if we calculate, it's going to be B minus B equals 0, A minus A equals 0, so it's going to be U. So it means A complements union B complements equal universe. This. And I want to continue to the next lesson about sets. Is about two basic counting rules. This, if A and B are finite sets, A and B are finite sets, so we can determine that we can state that first, n of A union B is equal n of A number element of A plus number element of B minus n A intersection B. For example, set A has elements 2, 3, 5, 6, and 9. So it means an A equal 5. And B has elements, set B has elements 5, 6, 9, 10, and 11. That is, so it means and B equal 1, 2, 3, 5 as well. So it means A intersection B. A intersection B, 5, 6, 9. So it means N intersection and A intersection B, 1, 2, 3. Okay, 3. So what A union B? A union B elements are 2, 3, 5, 6, 9, 10, and 11. So it means N, A union B equals 7. Now we are going to prove about this equation, this statement. N, A union B, based on this equation, this statement, that NA, how much? NA, 5. Plus NB, how much? 5. Minus N intersection B, 3. 10 minus 3, 7. So pay attention that N A union B equals 7. And based on this formula, this equation, the result as well, 7. And the second equation, is about N of A intersection B complements. And a number of elements A intersection B complements equal NA minus NA intersection B. Okay. If you evaluate this information, the set, okay, you can determine B complements. B complements elements are 2 and 3. So it means N of B complements equal 2. A intersection B complements. A intersection B complements. If you evaluate the previous sets, A intersection B complements elements are 2 and 3, same with B complements elements. So it means N of A intersection B complements equal 2. So I would like to show you this information that N A minus N A intersection B equal 5 minus 3, because NA, according to this information, that NA equal 5. Which one? Okay, so NA intersection B and A intersection B, according to this information, A intersection B equal 3. So 5 minus 3 equal 2. Pay attention. Look this statement that N of A intersection B complements equal this. So look that NA intersection B complements equal 2 and AA minus N of A intersection B as well equal 2.